All right, good morning, everyone. What an exciting time to be in Seattle and at this campus. Really, it's the energy around all these things that people are doing here makes me tremendously excited because we not only have a university that's very collaborative, but we also have so much work going on in so many different domains where I think we can partner and connect. And always when I talk to people about what's special about the University of Washington is the collaborative aspect at the faculty level. People really genuinely want to talk and interact. And so this is really an exciting time to be here. So I represent the AI Institute Dynamic Systems. This is a $20 million NSF funded effort. Dynamicsai.org if you want to go check it out. And what we're really after is sort of three primary thrusts. We want to develop fundamental mathematical architectures, which really bring together this idea of dynamics, control, statistics, optimization, all into a package that we can go and tackle some of the grand challenge problems in engineering. So really this is about control theory, ultimately at the end of the day, as any engineer would want to do, is you want to build a system and control it. So we're really focused on trying to bring those things together and using all the modern tools at our disposal to do that. And from that, we want to bring these out into grand challenge problems that we see that are out there in the community today, from things like the digital twin, where you can really bring all this architecture onto virtual production and industry lines, autonomy swarms, additive manufacturing, power grids. Seattle's an amazing place to be in terms of, even having places like Boeing being here and advanced manufacturing. Plus, we also have all of our tech companies around the area. So we want to bring all that into those. And we also want to, one of our big issues here is we want to bring out education and make this available for all. So we have a very big effort to open source all kinds of AI courses from very beginning undergrad all the way to the most advanced graduate students. And we're going to rely on people like you, faculty, who want to teach an amazing course, put it up online, have the data sets, code, everything available. So we're really excited about this perspective of how we can push this out to the broader community, including your grad students, your undergrads. It's all there, available at the level they need it and to ramp up, okay? So that's kind of our push as an institute. And we're doing this in partnership across the Northwest. Well, it's very heavily Northwest centric. So we kind of took this model out of the WWAMI model, right, which is the medical school model, which brings together Pacific Northwest schools to try to come together with the common infrastructure there. And so we're partnering with places like Montana State, Boise State, Portland State, Nevada, Hawaii, Alaska, which typically have not been represented in the AI architecture overall and infrastructure. And so we're bringing them in as partners along with Columbia and Harvard. And this was a very carefully chosen group of people who all have a common and aim and vision towards building AI in these engineering systems. And we have a really great balance of both. You can see I'm actually maybe one of the oldest on this list. So, and we have a lot of junior people involved with this and really are starting to have a group of people who can do the diversity of projects we have and have the diversity of skill set to bring to the table for this. So we're really excited. And if you ever want to get involved, especially in the educational aspects, you got a great course you want to teach, we'll put it up online, make it available to everybody in the world. So thanks for your time.
Imagine that you have a machine learning algorithms and you want to make it run faster, more power efficient, or you want to scale it up to process the large throughput of data. But the technology becoming more and more advanced, more complicated, and you have tons of the knowledge you learn in order to benefit the most optimal technology you can use. When you get into this kind of comeback that more algorithms, more complicated hardware, you cannot really try to learn both in order to optimize the best way to solve the problem. SED3 could be your solution. Good morning, my name is Shih-Chieh. I'm director of a new AI institute, A3D3. In our institute, our mission is trying to bring the real-time AI to an easy way, accessible for everyone. Then we can use that to transform science and engineering discovery. Our mission is try to push the boundaries of data processing beyond industry applications. In our institute, we assemble a collection of the elite scientists from each of the selected science domain and combine together the collaboration with the artificial intelligence algorithm expert, as well as the hardware engineering expert. We all come together trying to solve these real-time AI problems. What's the challenge we have? And looking at the current world, we are going to hit this exabyte scale challenge of the data science problem. And in Google, normally you are talking about per second of the latency for each inference calculation. And the data volume is about 10 to the 12 bytes per second. But the science, as a part of physics I have to deal with, is microsecond of the inference calculation, and our throughput is greater than petabyte per second. We are dealing with a problem more challenging than Google's processing per day, per second. Not just us, we try to reach out and start realizing our colleague from multi-messenger astrophysics and from the neuroscience, we are all sharing similar challenge. This challenge really bring a new way we can think about to advancing the engineering and also computer science. And we all together trying to cover 4 different research areas. First, we have the way can try to make the design of the machine learning algorithms and accelerating the machine learning algorithm on the hardware in 2 different territories. Then we can join together and trying to look for the common way we can talk. And we cover different scale of the science, the very tiny scale, try to understand the fundamental building block universe, part of physics, where I'm working on, and also the large scale geometric cosmic event in the universe, and how the 2 black holes merging and this tiny gravitational wave can be detected. And we also try to unlock the mystery of the brain. And all these are all unite together by investigating what artificial intelligence can giving us. And I fully resonate with Nathan. We should really try to target on how to train and educate our future generations and to advance our technology further. Join us. Thank you.
Okay. Good morning, everyone. My name is Maryam Fazel. I'm the director of IFDS, the Institute for Foundations of Data Science. So IFDS is an NSF tripods institute. Tripods is Transdisciplinary Research in Principles of Data Science. And it was launched in September 2020. And it was actually a culmination of a series of projects and funding from NSF. It was first the tripods phase 1 effort from 2017 to 2020, followed by 3 tripods plus X projects, followed by the big competition for the phase 2 institutes that we are one of the 2 institutes nationwide to be a phase 2 tripods institute. It's a 12.5 million 5 years NSF funding. So this is led by UW and it has partner institutions in University of Wisconsin-Madison, UC Santa Cruz, and University of Chicago. These are our partners. So the goal here, the big agenda, is basically we are motivated by issues that are wrong, that are not working, that are sort of missing in current AI and machine learning and data science. So one big thing is that the current key methods in data science can actually fail spectacularly due to corruption, manipulation, biases in data, and also for reasons nobody knows. And this actually poses a lot of deep questions. So it's a challenge for safety critical applications. In engineering, we do need to know what's going on. And it's also limits trust in algorithmic decisions, very big challenge from a social perspective. So this motivates us to try and develop a principled framework, leveraging the intersection of theoretical, mathematical, and deeper tools from multiple areas, computer science, electrical and computer engineering, mathematics, and statistics, to enable a better understanding of how these systems work, how do the algorithms work, and how to address all their pitfalls, leading to robust, privacy-preserving, fair data science algorithms that are able to perform well in a dynamic environment that is changing. So these are big challenges, and actually, as Mari pointed out, the issues, for example, that the algorithms cause in terms of fairness and privacy and robustness are all very fundamental. So the 4 themes of research of our institute are algorithms and complexity, robust data science, closed loop data science, and ethics and algorithms. We organize our problems under these 4 themes. The team at UW consists of the 6 faculty here. I'm the director. We have Zaid Harshawi from statistics, Kevin Jamieson from computer science, Dima Drusvyatsky from the math department, Abel Rodriguez, who's the chair of the stat department, and Yin Tat Lee from computer science and engineering. We also have local collaborators in companies like MSR, AI2, Amazon, Google, and we have a lot of faculty affiliates across campus. And I would like to invite you to please join us as an affiliate faculty if you're interested in researching in these topics. I would like to also emphasize, as you can see, this is a cross-college effort. It's engineering, but also arts and sciences, math department, stat department. So we are very excited about that and hope that it will be expanded even further. I would also like to mention, so we are interested in a variety of events, outreach, education, etc. And here's a list. Please see our website, ifds.info, for more information. But I would like to highlight, we have a weekly seminar, Fridays at 1:30 p.m. And monthly, once a month seminar that is across our 4 universities that is virtual. Please check it out. And this upcoming summer, we have a summer school on optimal transport. This is joint with the math department. It is IFDS and PIMS jointly organizing. PIMS is Pacific Institute for Mathematical Sciences. We also have a workshop on robust machine learning coming up in August. More information on the website. And I'd like to point out, just to show off a little bit, our research is really award-winning in many dimensions. This is a list of awards won starting from the 2017 Phase 1 grant, and very impressive. So my time is up. Thank you so much. I look forward to talking to everyone.
So back in 2020, when Maryam won her Tripods Institute, so on the side, NSF also launched the first round of AI institutes, 6 of them in 6 different topics, each one investing $20 million. So we teamed up with UT Austin to compete in one of the topics, which is foundations of machine learning. So IFML's goal is to make foundational advances in the state of the art of machine learning. And we have 4 research thrusts spanning all the way from very theoretical on the left to the very applied on the right. And all of these are inspired by our use-inspired research, which is focusing on 3 topics of imaging and videos and navigation. So all these thrusts are chosen as our solution or answer to a fundamental question we asked ourselves, which is, what are the most foundational challenges we need to address to keep AI on its current trajectory and make the most impact? So in thrust 1, we look at making foundational advances in the algorithms for deep learning. And this includes, for example, understanding the scaling laws of how much data you have and how big of a model you want to use, and the performance relate to each other. And Simon Du at the Allen School is one of the world leaders in theory of deep learning, who's leading one of these efforts. In thrust 2, we want to make our algorithms and models robust against dynamic data and distribution shifts. which means that when you deploy these models, the distribution that the data comes from might be different from the distribution the models are trained on. And we want to make our algorithms robust against such shifts. And Ludwig Schmidt and Jamie Morgenstern from Allen School are two of the world leaders in this topic of robustness against distribution shifts. In thrust 3, this is mainly motivated by our user-inspired research with our partners in medical schools to speed up their medical imaging and MRI. And we have current working system technologies that they're using, which speeds up their MRI by 10x. And this, for example, is using what's called deep generative models, which is a subfield of machine learning to make this happen. In thrust 4, we want to incorporate complex real-world constraints and objectives that cannot be written in a simple optimization. And we're focusing on two such applications. One in program synthesis, which is making machine learning that can learn to write programs for you from examples that you give. And another one is our user-inspired research on safe navigation. So the ecosystem of IFML is that we have about 30 faculty across 3 universities, Wichita State University, UT Austin, and UW. And we're working closely together to make foundational advances in the state-of-the-art in machine learning. We also work very closely with our collaborators and friends in industry, including Microsoft Research being one of the closest one. And we truly believe that the impact comes from the knowledge transfer with our institute and our partners. For example, we're working with UW Medicine to understand how human vision system works through machine learning. We work with other hospitals to make their MRI much faster. We work with big companies to make federated learning more secure and private. And we also work with other companies to make a global ecosystem for streaming services for videos. So these are the amazing people in the institute, and please feel free to reach out to any of us.
Good morning. My name is Mario Juric. I'm the director of the Institute for Data Intensive Research in Astrophysics and Cosmology. Let me tell you a bit of a story. So almost 20 years ago, in 2003, University of Washington with 3 other institutions came together to propose a completely new way of doing astronomy by, rather than going to individual telescopes and observing individual objects, to build one extremely large telescope that will be able to essentially download the sky, to image the entire sky every night, to put it into a database, to automatically process it, to make it possible for astronomers at UW and everywhere else in the world to do astronomy off of this data set. 10 years later, in 2013, the NSF and the Department of Energy approved this project as an MRUC project. It's actually the largest project ever currently being built by the NSF. And finally, after this 20-year journey in 2023, next year, this telescope is about to begin taking data. So with this one machine, we'll be able to image the entire sky and start answering some extremely important questions about the nature of our universe, all the way from the dark energy to the planetary system that we live in. We'll be able to map the distribution of matter in the Milky Way. We'll image something like 10% of all stars that are in the Milky Way, about 20 billion. We'll hopefully finally understand what dark energy is, or at least how it behaves. We'll be able to detect interesting transient and variable sources, objects that happen once in a billion, and we'll be able to search the solar system, all with the same data set. And the challenge of this machine, and where this project that we're just starting here, based on tireless efforts of many years of discussions that Andy led with the Schmidt Foundation, the challenge here is to put together a way for us humans to understand what is it in this data set of 40 billion objects that have been imaged over thousands of times with trillions of observations. So this is where really AI has to come in. We'll be getting something like 6 petabytes of imaging per night with this telescope. We'll be imaging about 40 billion stars and galaxies with 30 trillion observations in total. This is one of the first data sets in astrophysics that for vast majority of data, no human will actually ever look at the image. We need a different pair of eyes. We need many different, not pairs, but billions of eyes. And this is where AI is going to come and help us. We're developing things like classification algorithms, using physics-based, physics-inspired AI to basically tell us whether one of these 10 million objects that we'll see varying during the night is just a run-of-the-mill variable star, or it's a star that's being shredded apart by a black hole and really requires immediate follow-up. We'll be detecting anomaly detections, so objects that seem to be completely normal and then suddenly change because there's something interesting, some interesting physics going on there. And we'll also be able to take the imaging that we've taken from this telescope and then go beyond what's traditionally thought of as possible in signal processing in astronomical imaging. With more advanced AI techniques, we now know that we can take this telescope that we started building 20 years ago, thinking that we're going to go to a certain depth, a certain distance in the solar system. And then with advanced algorithms, with advanced image processing and object detection algorithms, with the same telescope, but better algorithms, applications of AI, we can go twice as far. So one of the challenges here is how do we, who are primarily astronomers, take all these new techniques, incorporate them into what we know best, which is astrophysics and physics, to make this happen. And one of my goals over the next 5 years is this exploration of the solar system is one of the most fascinating things that are going on right now. We really have a chance that if there is a 9th planet in the solar system, it will be discovered by an AI piece of AI software written by a student or a postdoc here at UW from one of the cloudiest places on Earth. So that's, I think, what we want to do, and I hope we can collaborate to make that happen. Thank you.
My name is Bill Howe, and I'm here representing the Information School, and in particular the Center for Responsible AI Systems and Experiences. We founded the center late 2020 in response to as the tools and techniques of AI proliferate, their interactions with fundamental questions in human values and the law and philosophy have become impossible to ignore, and in particular, their engagement with underserved communities. And so our mission with this center is to conduct foundational research in intelligent information systems and their interaction with those values, but also to think about development and deployment of such systems in practical context, and in particular, those that are underserved by market forces in the public sector, and also applications in the life, social, and physical sciences. So our funding is really a portfolio pooled together from our core faculty that spans federal agencies and foundations and companies, which really shows the broad interest in these topics, right? I mean, I started working on these topics in 2016, and we had to kind of pound the table to get people to pay attention. And now every big tech company and every medium tech company and a great number of small tech companies have some sort of department or initiative working in responsible AI or AI ethics. And so this is a opportunity for UW to continue to be a national and international leader in this space, and we want to help facilitate that. So we've been building a community campus-wide. We have a weekly seminar that we've been running for about a year, where we have students and postdocs and faculty from all 3 campuses and from 10+ departments around the Seattle campus, and not just from the usual suspects in methods areas, but also in the humanities and in the social sciences, where people are starting to pick up on these topics and wanting to study them. And that's really kind of core to our approach, is to blend these 2 approaches and have kind of joint research initiatives that involve a humanistic mode of scholarship, as well as an engineering and algorithms mathematics mode of scholarship. In education, we've been developing some new courses and also kind of reorganizing material in existing courses to put these topics more prominently. There'll be a directed research group in the iSchool run by Dr. Kaliskin next year. And we're also just starting to get started on a PhD certificate that would blend these 2 scholarship traditions. Our theory here is that the AI workforce in the future is going to necessarily include a diversity of thought that is not seen right now. It can't just be a bunch of engineers going forward. We've tried that and we see what happens as a result. So on the second slide, I kind of wanted to, I thought a little bit about what to push here, but I wanted to kind of highlight some of the recent research going on among some of the faculty. And in particular, Dr. Kalskin is a world leader in studying AI bias from a quantitatively rigorous approach that is also grounded in psychological theory, right? And so this gives us a different window into how to think about these things. So for example, what she's been able to show, her and her team has been able to show over and over again, is that these things exhibit human-like biases. So most recently, a recent paper that was submitted in NeurIPS showed that, you know, if you're familiar with these recent models, that you can give a text prompt and it'll generate an image for you, right? You can say, give me an avocado, give me a chair that looks like an avocado, and it will give you a photorealistic image of a chair that looks like an avocado. It's a great parlor trick. But if you give it a text prompt of a 14-year-old girl, you get sexualized and pornographic imagery some significant percentage of the time. If you put in a 20-year-old girl, it essentially doesn't even have a human anymore. It just sends back body parts. And the reason is that these models are trained on the internet, and the internet is an absolute cesspool of objectified images of women. And so this is just one of 10 or 20 different approaches that we're studying to understand this bias. All right. Chirag Shah is a world leader in search and information recommendation systems and has turned all of his attention towards bias. Tanu Mitra does fantastic work in credibility and misinformation and online extremism. And again, we have broad connections across campus. So we're hoping that you will come and join us if you're interested in these topics, if you want to have your students take these classes, if you want to join on some of the proposal initiatives that we're doing, anything else you want to do, here's some contact information on the left, and I encourage you to reach out. Thank you very much.
Morning. I'm Dave Beck from the eScience Institute, and I'm leading the new Scientific Software Engineering Center at UW. Whether we are explicit about it or not, software is part of everything we're talking about today. None of those advances, none of the amazing things that any of us are doing in this room would be possible without software. And all of us, I think, have the goal of treating our software that we create in the academic environment as a first-class research product, like a paper or a data set or a patent. And like a patent, you wouldn't write that by yourself. You would go to CoMotion, you would partner with the legal team, and you would get help putting that together. And that's sort of the idea behind the Scientific Software Engineering Center, is that we will help you take your pieces of software from an early prototype to a high quality piece of software that's used by the community. We're building upon a model that we have used for data scientists. So if you've been to the eScience Institute, you know that we have 14 data scientists that you can engage with. And if you don't know that, please come see me at any one of our breaks. I'll be happy to tell you more about that. And we're doing the same thing with software engineers, is really to professionalize the software engineering experience. So what I mean by that is giving a high level of engineering thought to the software. So design that will lead to sustainable software, testing and verification. Nobody here wants to be the next Reinhardt and Rogoff. We want our software to back up our conclusions that we publish. And finally, deployment. Putting software into the world is a hard thing, and doing it so that it's scalable and effective and usable by a lot of folks is difficult. So our goal of the Scientific Software Engineering Center is to help folks on campus, AI researchers and beyond, eliminate those technical barriers, surmount the technical barriers that inhibit the scaling of your software. Maybe you've got a CFD model in Fortran that you want to plug into your Python post-analysis code and render with D3 to the web. We can help you with that. I want to say that we're about more than engineering. So software is about working with people, and we are really interested in partnering with you to help build a community, to do a needs assessment of that community, and then deliver the right software that will help you and your team. So we're brand new. What we're doing is building a professional set of software engineers. So we're hiring directly out of industry, paying near market rates. And we are going to be responsible for providing a stable home so that you can engage with one of these engineers for 6 months, say, and then go away for a few years and come back for another 6 months. And we will have a home and a stable environment for those folks and career paths within the University of Washington. So if you want to learn more about how you can engage with us, please email me or see the website. I'm more than happy to talk to you about it. And again, if you want to know more about the eScience Institute and how we work with our data scientists in that model, please come see me as well.
So good morning. I'm Maryam Denolle, and this is Catherine. She's 5 weeks old. So I'm a seismologist, so I'm speaking here on behalf of our domain science experts. We deal with data that looks like this. We have lots of noise in our data. These are, you can see something that goes along the diagonal. This is a virtual wave or a seismic wave that travels from one place to another. We deal with a lot of that type of data. We deal with a lot of noisy data. And we are actually going toward a big data field. We're going with public archives of maybe 1 petabyte, although I just heard it's really small. And there's new types of sensors that bring us even more data that could be a petabyte per year, as against a petabyte that's been accumulating over 40 years. So this growth of seismic data is actually a problem for us because we cannot process it yet. We are limited by our ability to process it because we don't have good algorithms and software. And this is what our team is trying to handle. So I'm just part of one of the PIs on this proposal, on this grant from NSF to build a computational platform that would allow us to do both data and simulations. And it's led by Kartep at UAF. So public archives are going with exponential growth in seismic data. And I was telling you, we're kind of limited by our software. On the other hand, the wave simulation, so kind of numerical simulations of what these waves are, is quite a mature field at this point. It benefited from lots of numerical methods development over the past 40 years. And so we can make up any kind of wave today. We just need like bigger computers. And this field has actually gone way further than what our data field is. What are in our domain science is kind of divided between the wave simulation people and the data people. And they require very different computers. We want to be the bridge between a HPC platform that will help the wave simulation folks. And the side of our team at UW is to develop the cloud computing platform for the big data analysis. So we kind of designed a kind of pilot experiments for a cloud and HPC hybrid model for acquiring data, for processing data, and for delivering data products. So this is just a platform, a schematic of what we're envisioning. We started in October. I do find it very difficult to hire seismologists who are good coders. And the more I search, the more I have a difficulty for that. So maybe I'll go and hire the other way. But what I found is very interesting is those who really collect big data, there's so much to discover in this small bit of data that the seismologists focus on publishing that and not making these codes scalable enough. So we have so much to discover, but we're so limited by our software that it's something that I would like to tackle. So I'm the best spot in the United States to study this. And I've already got help from the eScience Institute and data scientists to start packaging our code and making them scalable on the cloud. And we've benefited from Azure, AWS, and thanks Scott Henderson for helping us in all this way. But this is going to be a model that will be the next generation of seismology, as most of our data archives are moving to cloud infrastructure. The community is just not ready, so we want to be the ones that train the next generation and train more senior scientists also on how to use the next platform for seismology. Thank you.
Well, that's a tough act to follow. I have no baby. So I'm Josh Smith. I'm joint in computer science and electrical engineering. And I'm here to tell you about the UW Amazon Science Hub, which just kicked off a couple of months ago. The Science Hub is a kind of umbrella agreement between UW and Amazon to allow collaboration. So there's an initial focus on AI and robotics. And the kinds of problems we're working on are things that, if you're not familiar with, say, robotic manipulation, you may wonder, what does that have to do with intelligence? So we're working on things like having the robot be able to pick up objects from bins and also being able to look at objects and detect whether they've been damaged. So Hans Moravec was an early pioneer of robotics and AI. There's a paradox called Moravec's paradox, which is things that seem like intelligence to us, solving calculus problems, playing chess, are actually relatively easy for computers, but things that seem easy to a 5-year-old, such as picking up an object, walking around, recognizing objects visually, are actually very difficult. So you can think of this problem of manipulation of grasping objects as a form of intelligence. Similarly, of course, computer vision, I think it's more familiar to people that is an intelligence problem. So those are the two sort of core areas of the hub initially. And we aim to expand the hub beyond robotics and AI with additional programs. So if you have ideas for things, Amazon is explicitly soliciting ideas for new pillars that could go within this hub agreement. So feel free to talk to me about those ideas. They actually have people at Amazon whose job goal for the next couple of years is to create these new centers. So in terms of how we're organizing this, we have the 2 sponsored programs that I mentioned, manipulation and vision. We also are giving out about 6 gift-funded exploratory projects per year. For this cycle has already ended. We've accepted the proposals already. We have a PhD fellowship program. So applications for that are due June 15th. So please have your PhD students apply for that if they're in a relevant area. We also organize community events. We've had actually 2 already, Northwest Robotics Symposium and AI and Robotics Roundtable. The walking robot that you see in the bottom, hopping robot, is actually brought up by Oregon State University. So they have been investing heavily in robotics in the last few years, and they actually brought more people to this workshop than UW did. So got some competition in robotics from Oregon State. If you have ideas for new programs, please contact me, and I encourage your students to apply for the PhD fellowship program. Thank you.
Good morning. My name is Shen. I'm the Associate Dean for Medical Technology Innovation between the College of Engineering as well as the medical school. Today, I'm very privileged to have the opportunity to tell you about the newest establishment of the Institute of Medical Data Science here at University of Washington. This is a really exciting effort across the board between the Faculty of School of Medicine, College of Engineering, and School of Public Health. The formation of the new institute is really a result of a year-long collaborative effort between the faculties of those schools and with strong support from the administration of these 3 schools. And here I want to show you the superstars of this team. These are the faculty leads that worked tirelessly together to make this happen. And they are really the driving force behind the initiative. And Professor Sean Mooney, that you see at the beginning, is the interim director of the Institute. Living in this pandemic, we're not out yet. We're forced to rethink about the current health and healthcare system. Data related to health and healthcare is generated rapidly every single minute, such as personal health information, medical records, and other ubiquitous sensors from individuals. So the Institute of Medical Data Science is really to leverage all these critical environments that we have at UW. We're very, very lucky to have to lead this transformation. First, I think we have UW Medicine. UW Medicine comprises about 50% of the UW's total business. And we are really an integrated system that covers the entire WAMI area, as Nathan mentioned. So we serve a very diverse population over a large geographic area. And we're really a living laboratory day to day that allows patient care, research, as well as education. More importantly, I think UW Medicine is data ready. Second, and that's what we're here for, is the College of Engineering has superstars, great talents in technology innovation, particularly in AI. And finally, we have our School of Public Health, which is really the world leader to tell us about the population health and help us to guide policy as we move forward in this complex world. So the Institute of Medical Data Science really is just the beginning of the UW's future for, I think, to lead the transformation of health and healthcare. For example, already UW Medicine has invested more than $200 million to be data ready. We have more than 30 years of data, over 5 million of patients' data right now to study. And there's also robust data governance in place, allow us to do this safely. And not only that we have a broad faculty involvement, over 50 faculties working on this area, and the open source data platform on the building the AI methods with the UW Medicine data has already attracted more than 500 data scientists globally. So I think to conclude this section that we saw all these really exciting new AI and data science approaches in all areas, I would actually like you to think broader in terms of how health and AI will be in the future. Traditionally, I think we think about healthcare as care for the sick, but I see that the new era of healthcare is more about nurturing the healthy. In addition to the personalized healthcare, we also should think about broadly about how our population health will be and how the environment will impact our policies and health, and data can help us to do that. Furthermore, I think the logistics, the hospitalization is very important for the insurance companies, as well as developing our cutting edge science and research. So I think at this point, we live in a very exciting area for a lot of exciting technologies as well as global challenges. And I think UW is in the right place. We have the right people, we're at the right time. And most importantly, we share the common goal to make this world a better place. So I think we need to seize this moment. I encourage all of you to make lots of connections and make our connections flow locally, but make our impact globally. Thank you.